All right, thanks a lot. And thanks a lot for attending, everyone. I'm going to talk about custom lenses and especially why do we need such a lens? I'm going to do that in few topics. First, it will be interesting to see what we mean by custom lens, what kind of level of customization there is, then the limit of the standard lenses compared to custom lenses. Important topic, money, how much it costs, and how much can we get our money back, basically, which quantity. And at the end, we will finish with some success stories and see why some customers selected a custom solution. Right, just a few words about myself and about the company. I've always worked in the optic industry. I've been with Schneider-Kreuznach for the past 5 years, and I'm coordinating the sales in the APAC team and doing some management of key accounts. And through those experience, I followed quite a lot of new lens development, and I will share this experience now. Schneider-Kreuznach is a pretty old company, founded more than 100 years ago in 1913 by Josef Schneider, and our headquarters is in Germany in Bad Kreuznach, so hence the name Schneider-Kreuznach. We have few offices in America and in Asia. We have three business units. I'm part of industry, and in industry, we are developing what most people know about us, standard lenses and standard filter, but actually most of our business is in customized solution and optical system. And let's see now what we mean with a customized system, a customized solution. So basically, there are different level of customization. The first one is a small modification, and I call small modification when it doesn't touch the optics, basically. Touching the optics is always tricky. So if you want to keep the cost down and everything fast, you should leave the optic untouched and just change the mechanics. And by changing the mechanics, we can already do quite a lot. We can we can change the mount here. We can remove the aperture and have a fixed aperture. We can add some accessories on top. It's possible also to do some ruggedization. Thanks a lot, Thomas, for the presentation. Ruggedization, automatization of the lens by selecting a proper material. We can add, I see that OptoTune is coming later in the presentation. We can add some OptoTune lenses to it. And we can also change the air gap of the lens. And by changing the air gap, we can slightly optimize the optical design without really changing it. So we still keep the same lenses, but with a slight air gap, and we can potentially optimize for certain wavelengths or working distance. So that's the first type. It's pretty quick, could be done in few weeks, potentially for the easiest changes, and pretty low cost. If you go to the next step, it would mean changing the optical design. And the next, if you don't want to have a full new design, you can start with an existing optical design and change it slightly to be able to match your parameters. So here, for example, we have a lens optimized for 0.5 to 2x, and we can modify some of the lenses. So it means modifying the center thickness, modifying the radius of curvature, modifying also the air gaps or the material of the lens. And if we are lucky, we don't have to modify every lens. Maybe we can just modify one or two lenses to achieve our goal. Then all the other lenses are still the lenses we use for our standards, for our standard lens, which is also saving a lot of time and cost for this development. So it would be the second type of customization. One type of customization that we usually don't think too much about is that a company has a history, and especially Schneider-Kreuznach, we've been here more than 100 years ago, and we have made more than 6,000 designs, and you can imagine that a lot of lenses were discontinued and the production stopped. People from internet cannot actually see that we discontinued some models, but they are looking for a lens as they think it should be a complete custom lens maybe, but maybe not. And if you ask your optic supplier, they might have some lenses actually matching your application without having to make a complete new redesign. So basically, it would be a revival of a discontinued model. And of course, you can do a complete new design of a lens. And one more level of customization is basically where you start the customization. So your optical supplier are optical experts. The customer don't have to be, and that's usually a place where people are hesitating to go to custom lens because they feel that they don't have the know-how, the knowledge to find out if a custom lens is needed and with which specification and so on. But yeah, there should not be any worries. The optical expert also have experience with the market, with the application, and can help to define the specification, the requirement for the lens. Some customers know exactly what they want and come with a full requirement, very precise, and we can start developing. And at the very end of the spectrum, it's possible to ask your optical supplier to manufacture a lens based on your drawings for the mechanics or the optics, for example, and it will be manufactured, assembled, and tested based on the customer's drawings. And in between, there is also the possibility to provide optical design that the optical supplier will then finalize and create the mechanics around the optical design before doing the prototypes. Every level of entry is, of course, saving time and money for the customer. So the main reason why we make a custom lens. So first is to match the application either mechanically or optically to boost the performance. The customer already tried a lens and he needs more performance and we can improve on this lens. Or it's a very unique requirement. There is no lens in the market existing already, and they want to have this kind of a unique lens and create a brand new lens for it. Or they want to optimize the costs. And that's one part which is not always known, is that a custom lens doesn't always mean expensive. A custom lens can actually save a lot of money. And I didn't speak with Georg from Dalsa, from Teledyne, but I also have my Swiss Army knife. And I like to compare not line scan cameras, but standard lenses with Swiss Army knife. Basically, the standard lens can do everything. You can use the same lens and bring it in space and look at the Earth from infinity, or you can use the same lens and put it in your machine and inspect some defect at the micrometer level. And this lens could also be used for high-speed application with a very open aperture, or it can be used for very broad depths of field. With a very closed aperture, you can have some lenses are used also for very wide range of wavelengths. So for example, going from visible to sphere, but some others will only use a red LED. But you cannot have so many lenses in your portfolio. You have to make a lens that is able to do all those parameters. And that's mostly for optics, but mechanics also plays a role. The lens has to be easy to use because some people don't care about it and will fix the focus position of the aperture once and for all and ship the machine to the customer. But then it will also be used by other customers for other applications, and they will need to change the focus and aperture maybe daily. And it has to be easy to use for both. And this mechanics also had the cost to the lens. On the other end, you have the scalpel. It has to do actually only one thing, and it has to do it perfectly. And it's the same as a custom lens. The custom lens is optimized for customer application, and it has to do it very well. And the same way as a scalpel, the custom lens can also have a lower cost than the standard lens. And that's the point now. Looking at a concrete example here, that's a standard lens with 16 millimeter focal length, 16 millimeter sensor size, so pretty wide. And the customer only want to use it at f1.8 with a magnification of 0.15x. He only wants then a fixed aperture, a fixed magnification. He only has also a red LED, and he doesn't need a C mount. He has his custom mount, and he is happy to glue it in place. So as you can see, when we optimize a standard lens to work for this application only, then we go from a 7-lens design to a 4-lens design. We reduce the size, we reduce the weight, we improve also the MTF. Yeah, with a much better MTF, much better over the entire over the entire sensor size, and because it doesn't need the ease of use of the mechanics, and it doesn't need also the the aperture, the variable aperture. We can simplify the mechanics drastically. So from 7 to 4 lenses for 15 mechanical parts to 6. It means the price, we reduce the number of parts of factor 2, and we reduce the price also of a factor 2. So drastic improvement in performance, reduction size, weight, and price. And if we go quickly and look at how quickly a customer will get his money back, basically for the development, the customer is saving about 300 euro per lens. The development of such a lens would cost about 70,000 euro, and after 12 months, the customer is basically breaking even. And after 3 years, there is a saving of about 150,000 euro. All right, so as a summary, um, a standard lens is great because you can get 1 or 2 pieces very quickly. It's often on stock, but the issue is it's not optimized for the application, and pretty often it's also more expensive when we are talking about let's say standard simple lenses. And one thing we didn't mention also is when you make a custom lens, you have a full control about the lifetime of the lens. It will not be discontinued. There will not be major changes without you knowing it. You can also choose what kind of acceptance terms you will have in terms of quality for the lens. So you have a full control over the lifetime of the lens. A few stories now. Success stories. So for one customer, it's exactly what Thomas presented with a ruggedization and the stabilization of the lens of the optical axis. A customer in 3D came to us with stereoscopic 3D and had an issue and had to recalibrate pretty often his camera, his 3D camera, and we found out it was because of the vibration of the environment and the optical axis was shifting. If the optical axis is shifting on a 3D camera, it means that you have an error in the depth measurement. And that's when we developed the stabilized lenses. Basically, same explanation. By stabilizing the lenses, we prevent the optical axis to move, and then the customer didn't have to recalibrate his camera due to the vibration around it. Here, it's close to the example I presented before. So basically, the customer planned to purchase a huge quantity of lenses and wanted to to reduce the costs. So we made a lens as simple as possible. It's actually this one that doesn't work. That's this lens to save quite a lot of cost, probably few hundred of thousand euros was saved by purchasing 10,000 lenses. Another topic is display inspection. In that case, it's a very unique lens. There is no such lens. There is not so many lenses on the market, and what the customer wanted didn't exist yet. So basically, with display inspection, the pixels are getting smaller and smaller, and the artifact or defect they are looking at is also getting smaller and smaller. But they need to keep the production speed going, and they need the largest sensor as possible. So, for example, I saw the DASA Teledyne presentation. One of the main camera used is a DASA 16K camera TDI, 82 millimeter length. So it's a huge sensor size, and the magnification has to go up to 5x, for example. So it's a um, very untypical lens. And they can go actually to a detection of defect down to 0.3 micron with such lenses. Here is another topic. They wanted to avoid switching lenses, so we made we made a custom lens with variable magnification, and they also wanted to fully automate the process. So instead of doing everything manually, as soon as a defect is found, the lens is automatically zooming on the defect, saving the image, putting for quality purpose, then unzooming, going to the next defect, and going further. So it saves a lot of time and prevents human error. Here it needed. It was a project with Facebook for VR with fisheye lens. Very special specifications. Also, no distortion. Pretty large sensor that they couldn't find on the market. And in this case here, it's a it's medical application, for pretty large sensors, also very high magnification. And the very important part of this one is that the customer wanted extremely high quality and wanted to be tested before delivery. And of course, this kind of acceptance terms are discussed with the customer. It was in that case very important, and we actually developed a new test bench, especially for this application. And also, one point is that sometimes it's very important, especially when the lighting is very complicated, to combine both. You want to see something, so you need a lens, but you also need sometimes some lighting. And combining both from the same supplier, the lighting and the lens design could help a lot, that you have only one partner doing everything. So don't hesitate. If your lighting is complicated, you can ask your optical supplier and ask if he can help. All right. That was all for the presentation. Yeah, we can now go to the questions.
First question, main issue is often the development time. Is there a way to shorten this time and to save money, of course?
Yeah. So it's always a tricky question. Because development always takes time. It's easy to have a simple design in theory, but then you need to optimize this design so that it's not that you get constant performance from batch to batch, from lens to lens. And then you need to have a lot of iterations with a tolerance analysis, and also not too sensitive to temperature and so on. So it's the development phase always takes some time, and then you need to do a prototype. You cannot really go around it, and then go to the industrialization with the purchase of the glass and the polishing and so on. So this process takes time. That's why a modification is often better. To modify a lens So either modify a small modification of the lens or modification optimization of an existing design. And sometimes a revival of a design is also much, much faster because the optical design already exists and it can be solved this way. Yeah.
Can the customer help to make this development time shorter?
Yeah. Basically, the easier the design, the faster it will be. So by not overspeccing, so it's good also sometimes to talk with a supplier about exactly the application, what the customer wants to achieve, and because otherwise it's easy to request for a specification which is much higher than what actually is needed, and by really specifying to exactly what the customer need, it's possible to reduce the development time.
Mhm. And how do you manage design updates or obsolescence for custom lenses over long product life cycles?
Yeah, so it's actually the very important point when designing your own lens. At least you have that in your hand. So on a standard lens, you would have you could be obsolete and you don't have anything to say about it, or we could change something of the lens, and you also don't have anything to say. So it's something also you can have in the agreement with your optical supplier. You can decide what kind of modification I want to be aware of. So for many people, as long as it doesn't touch the outlook or the performance, it's okay to have a small modification inside a lens. But for many customers, like in defense, in medical, in automotive, every single changes has to be brought back to the customer to be potentially uh, tested again by the customer. So it's something you can also agree with your optical supplier to be aware of every single changes in the lens.
Now we have a concrete question regarding modification of lens for specific wavelengths. How expensive is this customization? For example, for wavelengths in the near infrared range, about costs and complexity.
The near infrared range is not so complicated. So it's if the lens is already has a good transmission for infrared, it could be a pretty easy modification. Sometimes you can do it with just some air gaps. Sometimes by just changing one or two lenses, but I would say it's not a big modification. If you want to go higher in SWIR, it will be much more complicated. You also have to change materials and so on, but and some coatings. But many lenses actually in machine vision actually have a good transmission in the near infrared.